Alright, today's problem says, explain what would happen to the volume if the pipe from yesterday's bellwork problem was twice as long. So as a reminder, this is the problem that we did yesterday. So we had two cylinders the little cylinder was inside the big cylinder and the small one was hollowed out. So we had to figure out what the volume of this pipe was. So to do that, we had to find the total volume, we had to find the volume of the outer cylinder and subtract the volume of the inner cylinder because the inner cylinder was hollowed out. So when we did that from yesterday, we found that the total volume yesterday was 48.3 centimeters cubed. In yesterday's cylinder, our height was 3. So today's problem is asking us, hey, what if instead of having a cylinder where the height was 3, what if for this pipe, for each cylinder, the height was 6? So we need to figure that out. So remember, the volume is equal to the area of the base times the height. And I've already written down the area of the base of the outer cylinder and the inner cylinder that we found yesterday. So yesterday we found that the area of the base for the outer cylinder was 34.1946 centimeters squared. And then for the inner cylinder, the area of that base was 18.0864 centimeters squared. So we don't have to redo that work because we've already done it. Now we're going to use these numbers to find the volume. So here, the volume of the outer cylinder, we'll do that one first, is equal to the area of the base times the height. We know that the area of the base is 34.1946 and the height is 6. So now we're going to put this in our calculator. So the outer volume is equal to 34.1946 times 6. 205.1676 centimeters cubed. We looked yesterday, the volume of the outer cylinder was 102.5838 centimeters cubed. So it looks like it's definitely getting bigger and it might be doubling. So let's see what's happening here. Alright, then the volume of our inner cylinder is equal to the area of the base times the height. Well, we know that the area of the base for the inner cylinder is 18.0864 centimeters squared. And now we said that the height is 6 because we're doubling yesterday's height of 3. So on our calculator, we're going to take this and plug it in. So 18.0864 times 6. We get that the volume of the inner cylinder is equal to 108.5184 centimeters cubed. So for yesterday's problem, when the height was 3, the volume of our inner cylinder was 54.2592 centimeters cubed. So again, it's definitely increasing, and it looks like it might be doubling. To find the total volume, remember, we have to take the volume of the outer cylinder, so the volume of the outside, and we have to subtract the volume of the inside, the inner cylinder. So our total volume is going to equal 205.1676 minus 108.5184. So let's actually calculate this. 205.1676 minus 108.5184. We get that the total volume here, oops, let me get this on screen, is equal to 96.6492, which, if we're going to do our rounding to the nearest tenth, the 4 would keep the 6 as a 6. It would be 96.6 centimeters cubed. We need to figure out how does this 96.6 centimeters cubed compare to this 48.3 centimeters cubed. So far we've been saying that it looks like it's doubling, so let's see if it's doubling. Let's actually take this 96.6 and divide it by 2 to see if we get 48.3. So 96.6 divided by 2, Look, it's 48.3. So the relationship here is that when the height doubles, the volume doubles. So we're going to put here, when the height doubles, the volume doubles. And that is what would happen if we took the same cylinder pipe from yesterday, but we made it twice as long.